In this lecture, I will overview some important issues that you should be aware with respect to confirmatory factor analysis. And these issues are latent constructs, composites, and factor scores. And we'll also talk about exploratory factor analysis. So for a typical construct that you would measure with confirmatory factor analysis, we would have a set of items that are related to each other. So here the items measure perception management, and you can read them and see that they're very related to each other. So their correlations between them are expected to be high because they are measuring the same construct. So the principal lets staff members know what's expected of them. The school administration's behaviors toward the staff is supportive and encouraging. You can see how they are related. Also, because it's measuring a latent variable, these items are exchangeable. I could, for example, replace item 2 by the school's administrator's behavior toward the staff is friendly. And it's an alternative version that is supposed to be measuring the same construct. So there is nothing special about these items. They are just considered a subset of measures that prompt you to manifest that construct perception of school management. Another a more clear example is if I want to measure the latent variable mathematics ability, I can give you an infinite number of math items, and they are all measuring the same construct, mathematics ability, and the items are exchangeable. So I can be drawing from different people subsets from the same pool of items, still measuring the same construct. Now, contrast with a composite, such as teacher support. So here I'm measuring teacher support with a combination of school has an induction program, teachers are assigned mentors, teachers receive per-service preparation. Those are not indicators of a latent variable. They are variables that are being combined to create a composite. Those things don't need to be correlated. So a school has an induction program maybe completely uncorrelated with teachers receive per-service preparation. So the classic example of a composite is socioeconomic status. So you can get socioeconomic status, you can combine things like parental education, income, family income, and they're not measuring a latent variable, you're just combining them. Now, you can have observed composites, which is literally a combination. It could be an average of these three, or you could use structural equation modeling to create a latent composite where you try to get a residual. And this is complicated to do ESM, and it's not very common. It's a bit controversial to do. The most common is to just average or sum the indicators for the composite, the variables for the composite. So this is called formative measurement, and using indicators of a latent variable is called reflective measurement. So here is a summary of the differences that I already explained. A composite measured by formative indicators, factors measured by reflective indicators. Formative indicators are not exchangeable, reflective indicators are exchangeable. You can replace them. Formative indicators may be uncorrelated. Reflective indicators must be correlated because they are measuring the struct. And composites can have fixed weights, such as when averaging variables, you're giving them equal weights. Or you can get weights from the data. Factors have factor load is always estimated from the data. Now, exploratory factor analysis. Exploratory factor analysis is a method to summarize the correlation or covariance matrix into a small number of factors. So if you have 10 variables, you may find, for example, 2 factors that summarize the relationship between those 10 variables. It is a data mining method because there is no need for theory. The theory can be built post hoc, but you don't need theory in advance, which is completely different from confirmatory effect analysis. You typically, after you extract factors with exploratory effect analysis, you have to interpret them because they don't have meaning in advance. Since it doesn't need to be based in theory, you can interpret after you identify the factors. Now, so these are the differences between exploratory effect analysis and confirmatory effect analysis. Exploratory effect analysis does not require prior specification of factor structure. Confirmatory effect analysis does. Exploratory effect analysis estimates all loading, so all indicators load on all factors. In CFA, that's not true. Typically, we have simple structure in CFA, which is each indicator measures only one factor. EFA models don't need to be identified. So that calculation we have done where we look at the number of parameter estimates and the size of the covariance matrix, and the number of parameter estimates needs to be equal or less than the size of the covariance matrix for identification of CFA. That is not necessarily for EFA. And EFA allows for multidimensionality, but no residual correlations. So steps of exploratory factor analysis. You prepare a correlation matrix, implement a factor extraction method. So it is to identify the factors. There are several methods. Most common these days is maximum likelihood. Select the number of factors to keep. Because by default, exploratory factor analysis can extract as many factors as there are variables, but if you do that, you are not simplifying your data. So typically you keep fewer number of factors than the number of variables. The most common, most cutting edge method to determine the number of factors these days is called parallel analysis. Then you rotate the factors, which is like a spatial reorganization to improve interpretation. Then you have to interpret the factors, which means naming them. Typically, you look at the wording of the items that measured each factor and try to come up with an interpretation. Okay. Now, so these are some limitations of exploratory factor analysis. The number of factors may be sensitive to the criteria used. Sometimes it's very hard to interpret the factors. The importance of each item may depend on the rotation you use, and you don't need any theory, which is a problem. So this is considered, as I said, a data mining method. There is also a very common practice of create a scale using EFA and then try to use confirmatory factor analysis. Sometimes researchers get lucky and they find that a model developed with exploratory factor analysis also fits a confirmatory factor analysis, but that is not necessarily true, okay? Because a post hoc theory may not necessarily be supported when you have a CFA that's a lot more restrictive than an EFA. Now, there is also principal component analysis, which is related, but a little bit different than EFA. Principal components are linear composites, so they are a repackaging of your data. They take all the items and repackage their variance into a smaller number of components. However, there is no concept of measurement error in principal component analysis. It's just a repackaging. However, in EFA, you try to divide the observed variance into reliable variance and measurement error, and your factors are just based on reliable variance, and you try to exclude the measurement error. That's the main difference. Now, factor scores. Factor scores are actual scores on the latent variable. They can be obtained from either a CFA or an EFA, and they're very helpful if you are going to follow up a CFA or EFA, for example, with a regression or some other analysis that you need a score. or you just want to compare people with respect to a latent variable, you can use factor scores for that. Factor scores give you scores that are weighted based on the importance of the indicators of that latent variable. There are multiple methods to obtain factor scores. The regression method is the simplest. So you do it in two steps. First, you multiply the inverse of the correlation matrix by the inverse of the correlation matrix by a matrix of factor loadings. Therefore, you are weighting your results by how important the items are in measuring that factor, because that is the factor loading. The factor loading is a correlation between the item and the factor. And then you obtain z-scores, which is standardized scores for the items, and you multiply them by b, which are the coefficients you obtained from the previous step. And that gives you factor scores. So, I recommend using factor scores over just summing the items, because if you use factor scores, at least the items are being considered in the factor scores proportional to their factor loadings. While if you just sum items, you are considering that all items measure the construct equally well, and that's never true. Right? There are some items that will be measuring the construct better than other items. However, there are limitations with factor scores. They're not unique, they're only estimates of the true factor scores, the true latent state of a person, of a respondent. So there is still measurement error in them. So that's it.